About exception handling in Java today. Um, so what is exceptions? So except I don't think I have taught about this till now. So an exception is a runtime error. There are two types of errors. One is compiler error. The other is in the exception runtime error. So in the runtime error, why would you get to such a situation as runtime error? There are many situations that might come in while you are writing the code. The reason is because you think that some number divided by 0 should not happen. You know that, but there are people who there might be a situation where the in one of these functions you might have written where division is one of the things, and you by mistake somebody has calculated and the value has come to 0. Now the 0 is not something which anything divided by 0 is not cannot be handled. It will give a runtime error. That means the whole application will stop there and there itself. You cannot handle it. The machine, the Java virtual machine cannot handle that. So it will actually have to crash. So you don't want situations where your application when it is running have to crash. That would be the worst situation that can happen. So how do you avoid that? So you need to catch these kind of runtime errors. That means at the runtime, these things can happen. So how do you actually avoid such things? Is to see that you catch those kind of exceptions that which you could not thought of. Okay, compiler error automatically will be taken care. Why? The compiler error will never, if you have written the code wrong or the syntax itself wrong, it will never compile. So it will never go beyond that. Compilation errors can be dealt at the starting of an application itself. But these kind of exception errors which has to be caught while an application is running is something we need to handle it. So the default handler provided by the Java runtime system handles a few exceptions, but not every exceptions can be handled. Exceptions can occur when you try to open a non-existing file. You want to open a file, but that file itself is not there. So you want to append a file. That means that you are expecting that there is a file there, and you want to append that file. If you try to open such a file, it will give you problems. So we need to catch such exceptions. There is a network connection problem. You don't know whether the TCP/IP the other side is running or not. So you need to catch that network problem. So you need to catch that exceptions. Third one, operands being manipulated are out of prescribed ranges. There are so many things. I told one of the thing is 0. Something you are actually trying to get a method run out of an object, but object itself is not created. Now how do you catch that? It is null actually. So we need to catch that such kind of errors. So other thing is class file missing, which was supposed to be loaded. You said import something, right? You said import a package in this particular class, but that itself is not there. So how do we tackle it? And arithmetic exceptions, file exceptions, array bound of exception. You are trying to access a particular index which the array doesn't has not allocated the memory at all. So out of bound array exceptions. These kind of exceptions need to be caught. A few objectives can be pursued when dealing with processing in a program. Determine if modifying the existing code will eliminate the problem. So we have other things to do. For example, if you write a if problem, if exceptions, if while this is not going to happen, if this happens, then exit out of it. These kind of things can happen, but you cannot deal every kind of a problem that can arrive. Okay, so in such situations, we need to see that we need to handle them, and the exceptions need to catch them such that it catches the exception it can throw, and the JVM catches it and handles it properly without actually crashing the JVM. So that's what we want to do. So here you see that in this one there is a there is this right I is equal to I is equal to 5 by 0. You know that this should not happen. You should not even come to a situation where a number is being divided by 0. That means you need to catch that earlier itself, before the sentence comes to this level, the programming language comes to this line itself. We should be able to catch what happens when the code executed, exception is thrown, an object is thrown. How to recover from this kind of a problems? An error occurs, the program throws an exception object that is thrown contains information about the exception, including its type and the state of the program where the error occurred. So all these things will be given by the exception handler. Okay, where exactly it happened, why did it happen, in which line it happened, all these things you can identify, you can find the answer. Now how do you tackle this? Is by the Java exception handling is managed using these 5 keywords. You should write it down, or see that you in one of the email that I sent related to a particular website having this content, see that you read it. Okay, but anyway, I'm going to explain over here. These 5 keywords are very important. Okay, these 5 keywords are very important. Try. You're about to try something. If it fails, you need to catch. If you catch, you need to throw. You can throw multiple things, and finally you have to handle. So these are the things that it does. What it does is try, catch, throw, throws, and finally. Okay. Program statements that you want to monitor for exceptions are contained within a try block. If an exception occurs within the try block, it is thrown. Your code can catch these exceptions that are automatically thrown by the Java runtime. To manually throw an exception, we use the keyword throw. An exception that is thrown out of the method must be specified by a throws clause. Any code that absolutely must be executed before a method returns is put in a finally block. What it means is, I am going to do a throws. That means if a particular, if this throws has a, this one throw has a specific usage. Okay, this has a throw. The other 4 are used automatically in a particular program. In a let's say it's a public static void main. All these things can be done. And when I want to particularly see that if a problem occurs, I want to throw. I will extend. I will see that I will write a method which throws an exception clause. Then I will use this particular keyword. Throw is when I want to when something is thrown. Okay, thrown by the exception in the one when it is running the program. I need to catch this particular thrown exception when it is trying, and finally is the one where it is actually doesn't matter what happens in the rest of the code. Finally is the one which actually executes no matter what happens. Now let me give you an example, then only you will understand this. Okay, I know that it's confusing. When to catch, when to throw, when to when to throws, when to do a finally thing. I know that it was going to confuse. Okay, it will take some time. Just don't worry about it. I'll explain it. So here is some things. Okay, it's a skeleton of it. Okay, here is try. I write something over here. I write certain statements. Like for example, integer x is equal to 5, integer y is equal to 0, as the integer z is equal to x divided by y. Those statements will be there in the try block. That kind of statements will be in the try block. But when it is trying, if an error occurs, it has to be caught. So I'll catch it. Okay, I'll catch it. But here itself, I can say if I want to throw certain things, I can throw it without with the exception that there are certain exception class that I can write. Okay, I can override some exception class. Then I want to throw to that one only. But by default, there are some exception classes given by Java. It can be caught one after the other. There is there is a bigger exception class which is IO exceptions. Okay, IO exception. That IO exception is something which is a mother of all exceptions, exception class. But if you try to catch that, you will never know which particular exception it has. There are so many other internal exceptions. There are sub classes of the exception class. We need to catch specific exceptions only. Okay. For that to happen, we need to know what are those exception classes. So let's see exception handling in Java. How does it actually do? A simple try catch, a try with a single catch. Okay, where there is a try block and a catch block. Try with multiple catches, multiple exceptions, exceptions with exit code. There are possibly that exit code is also there, and that finally is the one. Throwing one own exception. I write my own exception class. Nested try catch block. That means within the try there is another try catch. Within that another try there is another try catch. That means there are 6 types of, how many? There are 6 types of exception handling in Java. Okay, these are the 6 different things. Okay, so exception handling is something which let's understand the hierarchy of it. This throwable class has the mother object, mother class, which is always the object. Okay, this throwable has two subclasses. One is error and one is exception. We are worried about this part of it. Okay, exception, runtime exceptions, and some other exceptions that are there. These are compiler exceptions and other things that needs to be taken care of. Exceptions and error. Exceptions are situation within. So this is just an explanation to that. So finally, now what is finally here? I'll give you a code. I'll finally show you a code which will explain all these things. I'll explain one by one. Then you will know about it. Okay. So try, catch, exception time, and finally. So we'll see that these things are understood. The finally statement is associated with a try statement. Identifies a block of statement that are executed regardless of whether or not an exception occurs within the try. That means this finally block, whatever sentences or whatever instructions that are there in the finally block, before exiting from that program, it will do no matter what. If there was an error also, doesn't matter. If there is an error in the try block, okay, it might go to the next catch exception, catch. But let's say if I put an exit there, it will not exit there. It will go directly to the finally block. In that finally block, whatever statements are there, it will execute, and then only it will exit. Till that point, finally will be fine. Till that point, it will not exit from that program. Finally is the final block which will be executed no matter what happens in the program. That much you should understand. Throwing exception. Use the throw clause to throw an exception, like something like this one. Throw new IO exceptions. Okay, I'll throw what it means. So basically a public void read throws IO exception. When it is done, it throws the new exception. See, this throws is here, which is actually a part of a function. Throw is one which actually is something which you throw from within the function or a method. So there are 2 types of things. One is throws, which is a kind of extends to a particular method. Throw is something which actually gets thrown from a method, which you need to catch. Like a ball, somebody is throwing a ball, that is an exception, and you need to catch the ball. That is the exception you need to. Okay. So throws, the throws keyword is used along with the declaration of a method that can throw an exception. When defining a method, you must include a throws clause to declare those exceptions that might be thrown but is not caught in the method. This tells other methods, if you call me, you must handle these exceptions that I throw. That means that you are exactly, for example, in a parent class, you want to see, you are trying to open up a network connection to another thing, okay, another machine, but you don't know, but you can handle it there, but you don't want to handle it. You want the subclass or the method where you are about to call that, it needs to implement the throws class, it needs to implement, it needs to catch those exceptions. If not, that method will not be compiled at all. So you need to use the throws class, multiple throws class you can do, throws exceptions, comma something, comma something. You can do multiple exceptions. Only then that derived method, derived class, wherein this method is going to be implemented, it has to catch those exceptions. Then only it will work. User defined exceptions. I'll show you an example about that, how to do that. So this is the theory part of it, okay, theory part of it. Now let's look at the code where it actually runs. I just want to show you this exception. So my exception, so this is something which, okay, so this, let me not do this. Okay, so this is something which is, okay, the class test my exception. They have written a class test text my exception, as it's supposed to be test my exception. Okay, public static void main of something. Here I am trying to get a value from the command line. Okay, that what I'm trying to get is y is equal to something. It is, I am trying to get a y, the value of y from the command line. X is already defined, so I'm doing integer z is equal to x divided by y. If z is equal to less than 1, I'm telling throw this exception. If I have commented out other things, why? Because I want to show you that if y is equal to 0, if y is equal to 0, what should be caught? Which particular exception should be caught? Divide by 0 error, it should be caught, right? Am I throwing here in this try block? Am I throwing? Is there a throw class? No, there is no throw class, right? There is no throw class, but it gets caught here. Divide by 0 gets caught. Okay, there are two catches. So first, you saw that there are 6 different ways to call exceptions in Java, right? 6 one. The first one is try catch block, right? Then the thing is try multiple catch, that is also there. Then try with a finally thing. Okay, try with a finally is also here. Okay, finally is also here. So I will tell you exactly how it works. So now let's me compile this. Okay, I'm compiling this, running, compiled it, running it. What is it asking? It is asking for me to do, give me a number 4. Now when I type 4, I did not print the actual value of z, so just don't worry about it. 4 is here. It took y is equal to 4. What did it do? It took y is equal to 4. So y is equal to 4 here. Z is equal to 5 by 4, which is 1 something. So z is less than 1, throw new exception. But I'm not doing that. Z is equal to 1. It is less than 1, throw me that exception. We'll do that part also. Okay. But what was there here? Error or no error, this line will be printed. Where is that particular line? It is in the finally. See this particular line will be called no matter what. Even if there is an error or not, this will be called. Let's see one more example of that. Whether there is an error or not, this will be called or not. Let's see. Let me do one more thing. Now I'm giving 0. So divide by 0 error comes. What does it mean? This particular exception is caught. Catch arithmetic exception. This particular exception has been caught. This has been caught, right? But finally it printed this also. right? I gave you 0, divide by 0, error occurred, error or no error, this line will be printed, right? This line will be printed. Finally will be called no matter what. That was what I was telling them. Okay. Now let me do one more thing related to my exception. This one, given data is not proper. So that means anything z less than 1 should be given a, should be told, should be caught, right? I will run this. Now why I'm giving is 9. Given data is not proper, give error. See, this line will be printed. I told you that this line will be printed no matter what. Now which one did it get printed? Because z is less than 1, this exception is going to be called. Given data is not proper, or divider was not proper, I could have given, don't matter, does not matter. Right now I just wanted to give you an example as such. What is that it is trying to tell? Okay, so that means now where did this my exception come from? My exception is actually over here, this one. I wrote my own exception class which extends from exception. Okay, which actually extends from exception. It actually extends from exception, wherein I am calling super of the message, which actually prints the message. When it has, when which message is it's going to print? The one which it actually is creating a new object with. Given data is not proper, right? I'm sending that string over there, and that string is what it is being printed over here. My exception, it comes over with a message, and that message is being sent to the super of message, which is the super. This is the exception, which is the super object for my exception. Parent object for my exception is the exception. What does this take? This takes a message which is a constructor within the exception class. So this is what is happening. Okay, now the one thing which you want to see is related to throws the exception. Let me see if I have such a example. The one thing which we need to see is that this is what is mean by throws my exception. Okay, if I put something like this, and which is public static void main throw my exception, that means in this particular method I have to handle my exception also as part of it, and it will take care of me when it throws my exception. It will be taken care over here. If even if I mention that over here, okay, if I mention here, and if I don't take care of it, it will give a compiler error. So that's what it does. Okay, so let's see if it compiles. Why? Because I have written this throws my exception, but and I am also taking care of it. I'm also taking care of it. That's the reason it compiled properly. So this is the gist of the whole exception class. Okay, and how it actually handles. Okay, and which takes care of the exceptions thing. Now there might be a, I don't know whether you could completely grasp the thing, but I will give you assignments in such a way that you try it at home and submit it, such that this can be taken care. That means you understand properly. Okay, this is a very important subject. Why? Because exception, without knowing how to handle exceptions, you cannot really write any kind of a program. Okay, we need to handle exception. It's like testing the code, and when you're testing it, you need to handle unknown inputs. There can be very, for example, you are here, remember, not in this one. Here I have given a kind of a integer y is equal to my scan dot next int, right? You are expecting an int to happen. Why should you think that the user is going to enter an integer only? Why not a float? Why not a character? Okay, I should be able to handle it, right? If I run it, It is expecting an integer. What if I type UE? This is the exception that will take care. So input mass mismatch exception. Did I handle it? I did not handle it. Now what happened? It gave me an error. I need to be able to take care of these kind of exceptions within that scanner. Within that, you are expecting an int. It should be an int. If that means I need to catch this exception such that I re-ask you the same thing. Please enter an integer. Only then I will allow you to go to the next level, next line. If I don't accept, if I don't handle it, this kind of errors will show up. Okay, so this is the reason why we tell you why to handle exceptions. If not, these kind of errors will come and it suddenly will halt. The whole program that you wrote will come to a screeching halt. Okay, so that is the reason to handle. That is the reason you need to handle exceptions. So